Hi there. In this video, we're going to talk about multiplying imaginary numbers and multiplying complex numbers. I have 5 examples for you here today. Let's start with example 1. This question says simplify, and it has 2 radicals that are being multiplied. Remember, 2 parentheses with nothing in between them means multiply. So to multiply radicals, we multiply the stuff in front of the radicals, and we multiply the stuff inside the radicals. We do that separately. So let's start with in front of the radicals. There's nothing here, but there is an invisible 1. So we're going to do 1 times -7, which is -7. And now we're going to do the stuff inside the radicals. -15 times radical 5 is negative radical 75. Now, we're going to simplify this some more because radical 75 or radical -75, that can be simplified. There's a perfect square that goes into it. The perfect square that goes into it is 25. That goes in 3 times. So remember, when you're simplifying a radical, you pick the largest perfect square that is divisible into it, and that's what you divide out. In this case, since it's negative, we also want to attach a negative to that perfect square. This -7 is just going to kind of float out front and wait for its turn. The answer to the square root of -25 is by pi. Remember, the negative square root can't technically be answered, so we attach a pi to it to show that it's an imaginary answer. And then we bring down this -7, and we bring down this radical 3, which can't be simplified anymore. And now we have 2 things out front of a radical. Those can be multiplied. -7 times 5. The answer to this question is -35i radical 3. All right, question number 2 says simplify I to the 77th power. It's kind of weird to just give us an exponent that's so large, but if we can remember these 4 facts, we will be able to do any I exponent problem. The 4 facts are I to the 4th is 1. It's a 1. I to the 4th is 1. I to the 1st is I. We can't solve that. I to the 2nd is -1. And I to the 3rd is -I. I'm going to put little arrows between all of these. If you can remember these 4 facts, you will be able to do any problem like this because all the problems like this just rely on knowing these 4 facts. So the reason I put arrows here is that this is a circle that we just keep going around until we get where we need to be. So if I want to get to I to the 77, I would go I to the 1st, I to the 2nd, I to the 3rd, I to the 4th, I to the 5th, I to the 6th, 7th, 8th, 9th, 10th, 11th, 12th. I would keep spinning around this circle until I get to 77. Now, that's going to take forever, so hopefully there's a shortcut here, and there is. If your exponent is divisible by 4, then it's going to be in this spot right here. If your exponent is not divisible by 4, it's going to be one of those 3 exponents. 77 is not divisible by 4, so I know that it's not this answer. And in fact, if I tell you that I want to go all the way around the circle, that's 4 possible exponents. That means that we're going to break this circle into 4s. So if our exponent is divisible by 4 with a remainder of 1 or 0.25, then this is the answer. If our exponent has a remainder of 2 or 0.5, then this is our exponent and this is our answer. And if our remainder, when we divide by 4, is 3 for 0.75, this is our exponent. Okay? And this one means that we have no remainder. There's nothing left over. It's divisible by 4. All right, so we just need to grab our calculator, do 77 divided by 4. And it's 19.25. It ends in 0.25. That means 77 is not divisible by 4. And in fact, 76 would land right here. So 77 would land right here. That means the answer to this one is The answer to this whole question here is 9. All right, if you don't understand that, we're going to do another example that involves those. We have a bigger problem that involves simplifying, but really it's just 4 high problems all smushed together. So I to the 58. Let's divide 58 divided by 4 on my calculator. I get 14.5. Now 14.5 means that when I spin around this circle, 58 will land right there because that says 0.5. So the answer to I to the 58 is just -1. We'll attach that 6 to it. I to the 18, if I do 18 divided by 4, I get 4.5. That means this one also is -1. 37 as an exponent divided by 4 would be 0.25. That means that I to the 37th is just I. We'll bring that 11 along. And then 53 divided by 4 is 13.25. That one also just ends up staying as an I. So all these huge exponents can just be simplified just by dividing them all by 4 and then checking to see what the remainder is. All right, so let's finish this question now that my phone stopped ringing. Let's simplify. These two have i's. Those two are going to be combined together. And these two just have numbers, so we can actually just do the math problem here. So 6 times -1 is -6. And this -5 times this -1 is going to be +5. So these two are like terms. After I simplify them, I can just combine them to get -1. And then these, we just have -11i. That can't be simplified anymore. And 8i, that can't be simplified anymore. But they're like terms. We can combine them. -11i plus 8i would be -3i. So that's our answer to this question. Kind of interesting that this huge, long problem just simplifies to this little tiny expression, you know. All right, number 4, simplified a plus bi form. Remember, when you have 2 parentheses in math with nothing between them, that means multiply. And in here, I see 2 things that are binomials that need to be multiplied, which means I need to use box method here. So we're going to set up a 2 by 2 box. Remember, you set up box method when you're multiplying more than one thing times more than one thing. I'm going to put -4 and 9i right there. And I'll put -7 and -2i there. And now I just fill in each box by multiplying. -7 times -4 is +28. -7 times 9i is -63i. -2i times 4 is a +8i. And then we're going to be careful here. -2 times 9 is -18. And I times I is I squared. Now, why did I say to be careful there? When I combine like terms, I get 28. 63 minus 8 is 55, so minus 55i. And then -18i squared. I can simplify this more. I know this is tempting to say this is our answer, but I squared, we know the answer to I squared is -1. So I can change that to be a -1. So 28 minus 55i times -1. -18 times -1, which is +18. Right? Negative times negative is positive. And now I have some more like terms to combine here. 28 plus 18 is 46 minus 55i. That can't be combined with it, so that's just part of our answer. They said to write this in a plus bi form. That means make sure when you write your 2 terms, you put the I last. We did that on the last question too, a plus bi form, but the I last. So the answer to this one is 46 minus 55i. And our last question for today, number 5, it says that a equals x and b equals 3i. What is the value of ab to the third? So all they're asking us to do here is plug in this stuff into ab to the third. So if a is equal to x, we're going to change a to be x. And b to the third means we need to raise everything right there to the third power. So I'm going to write it with parentheses like that. Notice how the 3 exponent is not touching the x because this exponent was not touching the a. Now I just need to do that question. What is 3 to the third power? That's 3 times 3 times 3, that's 27. And what's I to the third? That's I to the third. And then I to the third, if we use our circle here, I to the third is actually just equal to negative I. So we can change this x, and it's 27 times negative I. I'm going to put them all in parentheses for now. And then this is in an a plus bi form because there's not an a. It is only, these are all going to be lumped together in one term. And when we do that, we prefer the I to still be last. We prefer numbers to be first. So our answer here is 27xi. And let's move that negative up front. Usually we make numbers negative if there's a number in the product. So the answer to this question is negative 27x to the I. So that's multiplying imaginary numbers and multiplying complex numbers. Again, make sure you memorize this chart. This chart is very, very important that you memorize it. All right, that's all for today. Thanks for watching.